Can someone confirm? Am I audible clearly?
Yes, sir, you
Utkarsh?
are audible.
Yes, sir.
Okay, okay, very nice. Thank you. Okay, I will share my screen. Okay, good afternoon, everyone. And agenda for today's session is basically to solve all the PYPs for Industry 4. And like we know that Industry 4 is not offered during all the terms, so there are less number of PYPs. However, we'll go through the questions, and while going through the questions, we will be covering certain important concepts. And I will encourage everyone to pitch in so that it becomes a learning environment wherein we learn from each other. Okay, so with that introduction, I will start. So this is the December 23 previous question paper. And the first question, I hope my screen is visible to everyone. Is it
Yes,
legible?
sir.
Yeah, okay. So the first question is, which of the following functions logistics management does not cover? So if you see the options, supply management, it covers, materials management, it covers, distribution management, it covers. However, there is a striking this customer management. This is not the part of logistics management. So from it comes. Now, what is the last mile in a supply chain? Last mile is always to the customer. So when we see the first mile, second mile, and the last mile, from the manufacturer to the warehouse is the first mile. Second mile is from warehouse to the store, and third is from store to the customer. So last mile is store to the customer. Now, depending on the nature of the business, it can become a warehouse or it can become another thing also, or a distribution center also. So the correct answer is stores to customer. That is the last mile. What is the disadvantage of a product layout? So what is a product layout? We have got workstations, and one by one we keep on processing. Here we do, second we do, third we do. So what happens? What is the biggest disadvantage? That if any of the workstation it goes unserviceable, then it will have a disruption. That entire activity, the full activity, will get stuck. So if you see the options, limited opportunity for the use of specialized equipment, no, it can be used at anywhere. High per unit cost for production, no. In fact, the unit cost reduces. Movement of materials is tedious. It is not the right option. However, this last one which is there, not very robust if there is a disruption. So this is the most optimum answer. Identify the career progression of the industry. We know how we started steam engine, then assembly line, then IT, and then the IoT. So it is an easier one. Everybody will get this. The production rate of an assembly line is determined by what? It is always determined by the slowest action. That if you got the workstations, or sorry, the activities. So one is taking 5 seconds, another is taking 10 seconds, another one is taking 20 seconds. So the production rate will always be decided by the slowest one, slowest station. What is the decision variable Xij denotes in a vehicle routing problem? Xij in a vehicle routing problem, it is a binary, it is 0 or 1. It means just that if the vehicle has travels node J from node I. So there is an I, there is an J, and this Xij is equal to 0 or 1. If it is 0, it does not travel. If it is 1, it travels from I to J. Which of the following examples can be referred as cyclic patterns? So coming to the patterns, there are different types of patterns. One is called seasonal pattern. Seasonal patterns are the patterns which come in a at regular intervals. For example, winters or summers. And whereas the cyclic patterns which are there, the question which is asking, this is a pattern, however, it does not have any regularity. It comes with the irregular intervals. And example of this are some, okay, stock market crash. Nobody can predict when it will happen, but it happens regularly. Then economic recession, it happens if you see history. So the correct answer here is economic recession, or SA. Okay, the rest two options, okay, if you see increasing ceiling fan sales during winters, maybe the off-season discount is there. It is not random, it will be seasonal. Increased tourist football towards the end of the year because it is a vacation period. So again, it is a seasonal pattern. Only the economic recession. And another example I have said is stock market crash. Stock market crash. Then okay, you can say, any thing like COVID. Okay, so these kind of diseases they keep on coming, but at irregular intervals. No, this is a question which I saw had solved for DL. I hope I'm audible. Okay, still, can somebody keep on checking that?
Yes, sir, you are audible.
Okay, okay. So here in this document, I have covered okay, the different types of patterns okay, for understanding part. Okay, and already I have shared this document in WhatsApp. You can go through. So there are trend patterns. There are long-term increase or decrease in the data. It increase happens on a long term. Seasonal patterns, regular cyclic patterns are the one which are happen in the irregular intervals. Okay, now we come to this question. This question has already come in the quiz two. It is about complementary substitution and impulse buying. And Pranjal is shopping in a departmental store. He has a list of items which he prepared at home. He picked a few packets of tea. It means it was in his as part of his list. He could see coffee packets and milk powder packets in the neighboring shelves. He picked a few milk powder packets. So he has come for tea. He has purchased tea. He's taking milk. So milk and tea are they are complementary. However, these are not part of his list. He was searching for Good Day's biscuit. He could identify only one packet in the shelf remaining. However, there were a lot of Sunfish biscuits lying in the next shelf. So he picked 10 Sunfish packets. So this part is while he needed only two Good Day biscuits. Now map the scenarios with the items below. So we know tea, coffee, they are the substitution. If he did not purchase tea, for example, the tea was not available, then he would have picked up coffee. Milk powder he has picked up because it is a complementary. And Good Day biscuits and the Sunfish biscuit. Why he purchased Sunfish biscuit? Because there were no Good Day biscuits on the shelf. So this is an inventory dependent demand. That inventory was not there, and that's why he went for the Sunfish biscuit. That's why it becomes inventory dependent demand. What is impulsive buying? That okay, for example, he was on a counter, he saw something, and he purchased in impulse. That would have become impulse buying. However, in this case, there is no impulse buying. Now, this select the correct form of internet from column B corresponding to the example in column A. So, smart metering, banking system,
Hello,
entertainment,
hello,
integrated devices. Column B,
hello. I
consumer.
have
Hello.
hello. Yeah, I have a doubt regarding that milk powder. He
Yeah.
saw that milk powder packet was besides the coffee one. So shouldn't it be impulse buying?
No, no. See, okay, Zabia, there is only one difference here. This tea, he had come for the tea. Okay, I'll give you an example. Now, if he did, for example, the tea was not there and he purchased coffee. So this is a substitution. However, with both, for example, he has purchased tea or coffee. Now he needs like a milk. Milk was not there in his this shopping list. However, he knows that okay, milk will be required. So milk is complementing. So it's a complementary. However, on a counter, he sees some chocolates. Okay, he's paying the bill on the counter, and he sees chocolates. The chocolates they were not in his list, so he purchases five chocolates. So that will come under the impulsive buying. I hope it clarifies.
Yeah, thank you.
Yeah. Okay. So here we have to. So smart metering. If you see smart metering, banking system, and entertainment integrated device. So banking system, they are saying that correct form of internet, basically what kind of internet okay, use is there, whether it is industrial, consumer. These are the four types of uses of internet. So smart metering comes under the industrial use. It happens on a big scale. Banking system is a commercial one. Entertainment integrated devices like we have got Alexa and all that. So they come under the consumer part. Okay, so this next question is directly from theory. Which of the following model corresponds to the exponential smoothing forecasting model? So we have actual demand and then we forecast. So this is the we have got FT and we are doing forecast for FT plus one. So here we see in this This one is the correct answer. It smoothens the forecast by using alpha, and here we uses 1 minus alpha. If you see other options, if you see other options, there is no alpha there. So this is just a tip or a hint how to find the answer for this. Just give me 1 minute. My dogs here. Okay, I'm back again. So I give you the hint again where that alpha term is used again. That is used. Okay, what is not an example of digitization? So we learned again there are three types again. One is called digitization. Another is digitalization, and the third is digital transformation. So digitization is simply changing analog to digital. That is digitization. When you include that in processes, it becomes digitalization. And by doing that, there is a transformation in the business, then it is a digital transformation. So, which of the following is not an example of digitization? Scanning a document to get the PDF document, it is digitization. Converting a physical 2D sheet to a CAD drawing, digitization. Converting physical invoice to an e-copy, digitization. Creating an automated report from the existing cost data. This is not digitization. This is it will, I will say, we are involving in the process by which we are getting the automated report. And if you take in the terms of IT, then it will become digitalization. So the fourth option is the incorrect one. Next one, you visit the car center to get your car washed. In the service center, washing done using automated systems. Example, the car is put on a moving belt, water is sprayed, drying is also done. Which of the following term representing this scenario? So this is straight away automation. There is nothing digitization, there is nothing regarding digital transformation. It is pure automation. Choose the situations from the options below in which a facility layout problem is relevant. So what is a facility layout problem? That we have to decide where to look. First of all, what is the will be the layout in the facility, whether it is a product layout or it is a process layout. So if a new facility is added, yes, we have to decide about the layout. A new product is introduced, yes, we have to do. A new service is introduced, yes, we have to do. Shift in technology, yes, we have to do. So all four options, they are correct here for facility layout problem. Which of the following supply chain costs is or are affected by the distribution network structure? So inventory, yes, it is affected by the distribution network structure. Transportation, yes. Facilities and handling, yes. Information, yes. But the price which is there, it does not get affected by the distribution network structure, because price is always a function of demand. Now, many of you can say that, okay, sir, that in the distribution network structure, if your cost increases, then it will affect price. No. So, because price always depends on the demand function, and we have seen in the managerial economics, it is if the demand function is something like P is equal to, for example, 100 minus Q. So, it is not getting affected by the distribution network structure. I hope that is clear. Anyone, any doubt in this?
No doubt.
Okay. This is a straightaway Euclidean distance. Question asked to give us some marks. Okay, so now this another question. There are four demand points at these are the coordinates alpha 1 2 b 2 3 c 3 5 d 4 1. The respective demand at these points are 7 1 3 5. Select the optimum location based on the cross median approach. So in the lecture they I knew this. So in the lecture also the professor had covered, okay, how to solve these questions. So it's a cross median approach. So what we have to do, you plot this and solve it horizontally and vertical. 1, 2, 3, 4. This is 1, 2, 3, 4, and 5. So A is 1, 2. A is somewhere here, and its demand is 7. Or B is 2, 3. It is somewhere here. B, and demand here is 1. 3, 5. That is here, and demand is 3. C, and 4, 1, and next demand is here. D, and demand is 5. So what you do, you find it is a cross median approach. So first okay, we do, for example, horizontally. So horizontally, see, this is 7, 1, 8, D, and this is where it is here, and this is here. So here demand becomes 8, and here also demand becomes 8. So your location, we have to choose okay, somewhere here in between. Now the second okay, we solve vertically. So vertically, when we go 5 plus 7, 12. So here this is 12. This comes 3 plus 1, 4. It is here. So median of 7 plus 1, 8 is 8. So where is 8? 8 will be somewhere here. 8 cannot go here. So this will be the line. So this is 1, 2. So your point which is there, given the options, it cannot go beyond 2. It will be maximum vertically 2, horizontally between 2 and 3. So this is how you check the options. So the options 2, 2, yes, it is possible. 3, 2, it is possible. 2.52, it is possible. 2, 3, it is not possible because we cannot go beyond 2. So that's why this is the incorrect answer, and these three are the correct answers. Okay, the process layout. Process layout is also known as batch production layout or the functional layout. Just remember this. Okay, this we have solved. Okay, now we come to, okay, this is an important part. A factory works for 2 8-hour shifts each day and produces a total of 24,000 electric bulbs using a set of workstations. There are 8 activities required to manufacture the bulb, such that the sum of all activity times equal is 12 seconds. How many workstations are required to maintain the specified level of production, assuming that activities can be combined into those workstations in any order? Enter your answer in the integer value. So this is from week 1 to 4, and how we have to approach this question. We have to find first of all the cycle time from this data given, that there are, what is the total time, what is the total output, and total time divided by output gives you the cycle time, current cycle time. So it comes 12 by 5, 2.4 seconds. Now it is also given that total time to produce one bulb, and it involves 8 activities, it is 12 seconds. So the formula for number of workstations is total time for all activities divided by the cycle time. So this becomes 12 divided by 2.4. So your workstations will become 5. Okay. Is it clear again? Or shall I repeat again? So how to approach this question? Total output, total time taken. So we find the cycle time from here. This is the current cycle time. Then what is the total time for these 8 activities, which is 12 seconds. You divide this 12 by 2.4 and you get the number of workstations. This kind of questions we'll be solving in another PYPs also. So with time it will become clear. So this is the important concept. Cycle time is equal to total time by output, and number of workstation is total time for activities and divided by time of activity with max time. That's the mean cycle time. And here only if the question comes for the idle time efficiency, these are the formulas which we know. Okay, the next question is the newspaper model question. Ramu puts up a stall for Diwali light every year. He builds a diya at a cost of rupees 3. earns rupees 5 by selling each diya. So profit he earns on every diya is 2, which becomes his CO. Any diya not sold by Diwali will be discounted to rupees 1 from his. So rupees 1 cost was 3 and he's selling at 2. So cost of salvage is 3 minus 1 is equal to 2. So both CO and CS, they become 2. So what is the critical ratio? Critical ratio formula is CO divided by CO plus CS. Whatever you want to write, CS, CC, whatever, till the time you understand. So this will become 2 divided by 4 is equal to 0.5. Basically, this CO which is there, this is the amount which he foregoes if he does not have the item. So for example, it is the profit. So 5 minus 3, if he did not have the item, so he foregoes 2 rupees. And the CS is the amount which he foregoes due to the salvage. So his cost was 3 and he's selling at 1. So 2 rupees is his salvage. He foregoes in that, his loss. What is the optimum order quantity that minimizes Ramu's total cost? So for this, okay, you need the distribution. So distribution in this case has been given 800 to 1000. So for uniform distribution, straight away formula is that this part 800 plus the critical ratio which has come divided by 1000 minus 800, and you get the answer 900. Percentage change in the order quantity if the demand support changes to 500 to 700 means the distribution changes. So in that case, you apply the same formula and you get Q2 is equal to 600, whereas here the Q star was 900. So they have asked the percentage change. So it will become 900 minus 600 divided by 900, and it is in minus because it is 600 minus 900. It will become minus 33%. Okay, till now, any doubt, anyone?
No, sir.
Okay. Okay. So now again, the next question is regarding the same concept which we covered just earlier. Rana Bakery, a company, is using a layout which consists of 9 workstations. There are 200 sandwiches are produced in a day on this layout. A typical day consists of a single shift which runs for 10 hours. The sandwich making process consists of 9 activities because there are 9 workstations. The information is provided in the table below. And the question is, what is the current efficiency of the line where each activity is performed on a separate workstation? So first of all, we have to find the min cycle time. Min cycle time will come from where? It will come from this part. What is the time and what is the production? So this we utilize to find the min cycle time. So min cycle time, there is a 10 hours shift, and all this is in seconds. So you convert this in seconds, and so min cycle output is 200. So your min cycle time is 180. Now percent idle time is nothing. Either you can directly find the efficiency or percent idle time that for each this you find. So 180 minus 20 is 160. 180 minus 10 is 170. So like this, you find the idle time for each workstation. Divide by number of workstations into the cycle time and into 100. So this will give you the percentage idle time. So this comes around 88.88%, and efficiency is nothing but 100 minus percentage idle time. So this how. So important step is that you find the cycle time using the total time and what is the output. Now for each activity using this min cycle time, find the idle time. Using that idle time, you find the percentage idle time, and then efficiency becomes 100 minus percentage idle time. So these are the steps for this. Okay, till now, any doubt, anyone? Because the next question is slightly lengthier one. it will take some time. So can we take around 2 minutes of break?
Sure, sure.
Yeah. Okay. I'll have a glass of water and I'll just come back. Yeah. By that time, just go through, and if there is any doubt, we can discuss.
I guess you are speaking on mute.
Okay. Okay. Okay.
Y-
Any question,
Uh,
anyone? So before we
yeah,
start this
one
question.
minute. Could you please explain that cross median approach problem alone once again?
Okay.
I
Okay.
had some
Okay.
internet issues and things.
Okay. Cross median approach. We had solved it here. So see,
Hmm?
uh,
Plotting points, okay, but after that,
after that plotting points. Okay.
yeah.
So see the median which came. This point is clear. 8 8. How it came. So this becomes easier.
No, 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 not clear that 8 8. Yeah,
Okay. So see, hmm, what we have to do first. We have to do horizontally, and then we have to vertically. So here, see, demand is 7. Here demand is
yeah,
1.
yes,
Here, if you take progressively, so this is 7, this becomes 8, here it becomes 11, here it becomes 16. Just give me,
yeah, correct, correct.
just give me 30 seconds. Hello.
Yeah, yeah,
Hello.
you're audible.
Hi,
Yeah,
Suraj. Okay, so if you go horizontally here, just hold on. So here it is 8,
yes,
and if you come from here, this here demand is 5 plus 3, 8.
yes,
So your median is here.
yes, yes,
So you
yes,
can select any point either at 2, or you can select at 3,
correct, correct.
or at 2.5, anywhere.
2.5, correct.
Okay, now you use the same approach now vertically. Now this
Okay.
is 5, this is 7. So here it is 5,
Hmm?
here it becomes 12,
Yes.
13, 16.
Hmm?
So your
Yes.
median point which is there,
Hmm?
where it will be, the median of 16 is how much? Around 8.
Yes. 8.
So 8, it will be somewhere here. Okay, now if you check the location, so this will be the,
Okay.
okay.
Correct. Yeah.
So that's why I said ki it cannot be 3.
Oh, okay. Got it.
Okay.
Got
Yeah.
it. Yeah.
Okay.
Thank
Okay. Okay. So next question is a Bellman question, and if you remember, this question we had solved during our revision for quiz 2 also. So, and it has come in P by P, December 23. So suppose you are responsible for material purchase in an organization, you had demand forecast for a product for next 4 weeks, which are 3, 4, 2, 4, and 4. These are the demands. You need to purchase one type of raw material to produce the final product to meet the above demand. Consider 1 unit of the final product requires 1 unit of this raw material. Whenever an order is placed, you organization needs to incur a cost of $4 irrespective of the quantity. This is a fixed cost. Purchasing cost of the raw material is 2 per unit. This is variable cost. Holding cost of an item not gone for production at the end of a week is 5 cents per week. You can order a maximum of 5 units in a week, and the warehouse has a capacity to store only 4 units of inventory. Okay, so and then on the basis of that, we have to solve this Bellman equation that every period, okay, how much we'll be ordering. So if you see, I have drawn this. So these are the periods 1, 2, 3, and 4. Now at every period, here when we start, this is S0, this is S1, this is known as the start state variable, S3. And in the Bellman, what we considered that in the starting it was 0, and we finish again when at the end of the 4, then we have 0. And the actions which we take here are known as the actions. So how to solve this? We do the Bellman. We start from the last again. So in the last, what do we calculate? For example, at week 4, the state of S3 can be either 0, 1, 2, 3, or 4, because in the question it has been given that only the 4 maximum units can be stored. Is that clear till now?
Yes, sir.
Yes. Okay. So now for this S0, S1, S2, S3, S4, finding F4, like we find F4, and if it was 0, now we know demand for the this is 4. So if this is state is 0, he has to order 4. So in that case, 4 is his fixed cost when he orders. Item cost is 2 into 4. So this becomes 12. Similarly, F4, if it was 1, he orders 3 only. This becomes 10. F4, 2, he orders 2. It becomes 8. F4, 3, he orders 1. So it becomes 6. If it is 4, F4, 4, then he orders nothing, 0, and the cost becomes 0 because there is no, he's not ordering anything. So this is a trivial. For the last state, finding the F4 is trivial. So now what do? We write again these values here: F40, F41, F42, F43, and F44. This is the first step. Now we go to state 2, S2. So now, sorry, this is S3 or S4 at 3. Now again the state can be how much? S0, S1, S2, S3, and S4. And what is his demand? His demand is 2. And he can carry maximum how much? 4. So if it is 0, then he has a demand of at least 2 and can demand maximum 5. So what he does, for example, at S0, he demands only 2. For example, in this case, I have used this notation that F3, his state is 0, he demands 2, cost of demand is this much, he does not carry anything, so there is no holding cost. Now he's not carrying anything, so F40 comes into the play, which is 12. So this value becomes 20. We come F30, state is 0, he orders 3, consumes 2, so he carries 1 forward, so holding cost for 1, and then we use F41, this. So this becomes 20.5. So this how we calculate for F3. Now similarly, if we calculate this for all the states, So this is calculations are easy, but it takes lengthier time. So just be careful with your calculations. Now this is for if his state is 1, he can order 1 and he can order maximum up to 5. So use the same principle and you will get these values. Okay, so these values they have come. Now again at 2, the time step 2, again his state can be the same 0, 1, 2, 3, 4, and his demand is 4 in 2. So he can order maximum how much? Okay, he can order either, for example, at 0, he can order either 4 or 5. He cannot order more than 5. He has to meet his demand. So at minimum he has to order 4. So this get F20 4 is 32 and this is 30.5. At S1 he can order 3, 4, 5. So you find the values for that. At 2 he can order 2, 3, 4, 5. So these are the values. At 3 he can order 1, 2, 3, 4, 5. So these are the values. And at 4 he can order only 0, 1, 2, 3, 4. Why? Why he cannot order 5? Because he cannot carry more than 4. It's not allowed. So these are the values for that. Now with this, now you come to S is equal to 0. Now S is equal to 0. His demand is 3. So his order has to be 3. He is starting from 0. And maximum he can order 5. So S03. Now what do you do? If his state is 0, he demands 3, consumes 3, does not carry anything. So he reaches F20. So you go to the F20 column. So here you will come F20 and you take the minimumest value, most minimum 30.5. So this is the ideal. So this is the value. If he's 0, he orders 4, then he consumes 3, holds 1, and you reach F21. So this value is 39.5. If he orders 5, then he carries to F22 and this is 40. So from here you can clearly see that 39.5 is the minimum. And now you start going that minimum is S0. So what he does at S0, he demands 4, he reaches F21. Now you go to F21. This is F21. So now this is F21. F21, which is the minimum most, is 27. So what he will do at second stage, he will demand 5. And now you go to F32. F32 you go. This is F32. F32 is minimum is 12. So at third, okay, he does not order anything. And he reaches F40. So now you go. So this is how the Bellman is solved and how it is interpreted. So the interpretation also I have given. So you can go through this. Okay, any question for this or any this? Okay, we are doing. We had done already this thing during quiz 2 revision. Anyone? Any question in this?
No doubts.
Okay, very good. I remember Suraj, you were there during that revision session, no?
Yeah, I remember. That was clear, yeah.
Yeah.
It was we done stepwise. It took half an hour, I guess, yeah.
Yeah. No. Once you practice, okay, you can do under 10 minutes around.
That was very clear, I'm saying, yeah.
Yes.
Clearly,
Basically, that time you were solving, okay, with the to make everybody understand.
Yes.
Once your understanding is correct,
that's fine, yeah. Once is enough, yeah.
Okay, so now the next question is, what is the state variable represent? State variable is basically the starting. That what is your state? Okay, S0, S1. So whether it is 0, 1, 2, 3, 4. So beginning inventory with the warehouse in each week. What is the action set? Action set is that how many units of the raw materials needs to be purchased in a week. So it could be 1, 2, 3, 4, and maximum 5. So these are the action set. What is the objective function value in stage 3 when the stage variable is 2 and your action is 0? So this is F320 basically, and we had calculated it was 12. So I'll advise everyone, you just solve this question once or twice, and then you'll find, okay, you can do, under 10 minutes easily. Okay, next question is from week 9 to week 12. Suppose you need to accept a reservation for a flight. There are total 100 seats. You have two classes of passengers, economy and business. One economy seat gets you 2,500 rupees revenue, while the business seat gets 7,500. From your experience, you know the demand for the business traveler follows a uniform distribution 10-40. Then answer the given questions. What is the booking limit and what is the protection level? So remember, the booking limit is always for the economy. The protection level is for the business class. Okay, in the answer key opposite has been given here. However, in the discourse, Gemini has clarified that it is incorrect. So these are the correct answers. And how do you find the answer for this? Simple formula. You find Py star is equal to 1 minus Pe by Pb, where P is the economy revenue, PB is the business revenue. So Py star will become 1 minus 2,500 divided by 7,500, which becomes 2 by 3. And you straight away put this in the uniform distribution. So this is the uniform distribution. So this is like your critical ratio, which we used during critical ratio in newspaper model. So your y becomes y is equal to 10 plus 2 by 3 into 40 minus 10. This becomes 30. So, and this gives you the protection level for the business class. So this is the business class seats which you should keep, and 100 minus y is equal to 70. This is the economic class. So this is an important question. In most of the PYPs, this kind of question has come. So remember this formula: Py star is equal to 1 minus P by Pv, and then you find y, which is the protection level, and subtract this from the total number of seats. You get the booking limit. Okay, which of the following examples can be referred as a seasonal pattern? So like I covered earlier, it is a regular interval. So what comes under regular interval? Not the economic recession. Increases ceiling fan during winters. Yes, it is a seasonal pattern. Increased tourist football fall during the end of the season. Yes. So with this, we have completed the December 2023.
Hello.
Hello.
Yes, sir. I have one doubt.
Yeah.
Sir, what is the protection level actually?
Protection level is see, you have these many number of seats. So, and there are two types of customers. One is the economic customer, economy class, and the second is the business class.
Okay, sir.
Okay. So now you know that the business class will also come. So out of this total, for example, 100, how many seats should I keep for the business class? So that is known as the protection limit.
Okay, sir.
For the economic, it is known as booking limit.
Okay, both things are same.
Yes.
Both things are same, just the different names for different classes.
Yes, yes. So booking limit, always remember, it is for the economy.
Okay, sir.
Okay. And for the business, it is a protection limit.
Okay, sir.
Okay. Yeah.
Thanks.
Okay. Welcome. So now we come to April 2023. Now I'll slightly go faster because most of the questions are common. So this is in which of the following scenarios a facility layout problem is relevant? This already we have covered. It is a repetitive question. Select the disadvantage of a product layout from the following. Lack of flexibility. Yes, okay, because everything is going sequential. So can you decide that I will produce this here? So it is that flexibility is not there. High risk if a machine breaks down, then the entire line stops. Yes, we have covered earlier. This is one of the biggest disadvantage of the product layout. High working process. No, this is not. Need a specialized supervision. No. In this case, if you remember from the week 1-2, it was clearly given that product layout does not require specialized supervision. Whereas the process layout, okay, there we need specialized supervision. What are the inputs for order up to level calculation? Order up to level means that we are there and how much we have to order so that we meet the demand. So it includes sale forecast, yes, lead time, how much time it will take the item to arrive, on hand inventory, how much I have got presently, and what is the safety stock, how much I have to keep, okay, so that I can meet the demand. So all are valid, okay, for the order up to level calculation. Digitalization, we have covered earlier, digitalization involves processes. It is not simply analog to digital. So pure analog to digital, it is a digitization. No. Use of digital technologies to change the process. Yes, it is a digitalization. Process of moving towards a digital business. Yes. Again, it is a digitalization. Encoded in a digital format. No, it is a digitization. Okay. Which of the following statements choose Euclidean metropolitan? I will leave it like a trivial question. Which is the of the following is or considered in the vehicle routing problem VRP, but not considered in TSP? What is not considered in VRP? But so subtour elimination we do in both. You can see the algo. Any capacity restriction, yes, we do. A specific starting point we do in VRP. Uh, Distance traveled restriction, it is for both. So in the TSP, if you remember, there we don't use the this in the TSP we don't use the any specific this starting point. Okay, so this is the correct point. Do you remember TSP? It used to be there 1, 2, 3, 4, but there is no starting point. Whereas in the VRP vehicle routing problem, we have got a store and he has to order. He has to fulfill the orders. Whereas in the TSP, it gives you the minimum distance and or the route which is there. So the third point is a valid point. It is there in the VRP, but not there in the TSP. What brought the first industrial revolution? We know steam engine, and from there you can make out mechanization. 7 principles of IoT. Please go through these 7 principles. Big analog data, it is there. Quality control, it is not there. Constant connection, it requires. Real time, it has to be there. Spectrum of insights, it is there. So just go through those 7 principles of, if I'm not wrong, it is in week 8. And this is not the part of those 7 principles. What is the decision variable Xij denotes in a traveling TSP? So remember in VRP what we had said, that Xij was that if you are going from I to J, Xij could be 0 or 1, meaning that whether you have to traveling from I to J or not. So if the sales visits node I from node J from node I binary, yes, it is correct. If the sales visits node J immediately after visiting node I binary, so this is the correct answer immediately. But if you see the English, they both mean same to me. Anyone finding any difference here okay, with me? Zadia? Suraj?
Yeah, finding a difference. Yeah.
What is the difference? I cannot see any difference. If the sales visits node J from node I, or if the sales visits node J immediately after visiting I,
Correct. Yeah,
they both
immediately
are
after.
same. Okay,
Yeah.
so they both looked same. Okay.
So what was the answer ki they said?
Answer they have
Second.
given okay, this second. Okay. But if you see
Okay.
English, okay, the first one is also correct.
Correct. Immediately
Yeah.
they are coming to say.
Which of the following is digitization? Digitization analog to this conversion of physical 2D trying to CAD, creating PLC logic in a microprocessor based system. It is digitalization, so it is not there. Providing real-time maintenance schedule based on real-time machine performance. It is digital transformation. So remember, digitization is basically analog to digital. Okay. Now, at EOQ, the order cost is minimum, lower than the carrying cost, or equal to the carrying cost. So, at the economic order quantity, always the order cost is equal to the carrying cost. And here I have given one example just to understand. There is a company, the demand for widgets is 10,000 per year. The ordering cost is $100 per order, and carrying cost is $2 per this. So EOQ comes 1,000 units. Now, at this order quantity 1,000, the total annual order cost equals the total annual carrying cost, ensuring that the company is operating at the most cost efficient. So at EOQ, the ordering cost is equal to the carrying cost. Just remember this. This is a simple one. If I remember correctly, it had come in Q 2 also. So all of us, we can do that. This is cost, this is quantity. Okay, so this I will not touch upon. Okay, calculate the metropolitan distance. Metropolitan distance is nothing but Manhattan distance, and we know how to calculate that. It is absolute of y2 minus y1 plus absolute of x2 minus x1. Okay, so this next question is EOQ model. Ashok Equipment Company estimates its ordering cost of rupees 400, carrying cost to be rupees 2 per year per unit. Estimated annual requirement is 10,000. This is demand. At a unit price of rupees 10, calculate the given sub questions. What is the economic order quantity, EOQ? So EOQ formula is 2DCO by CC, where this is the ordering cost and this is the carrying cost. So you put this in formula and you get 2,000. Calculate the number of orders per year. This will become D by Q. So demand, how much is demand? Demand is 10,000 and Q is 2,000. So number of orders will be 5. Calculate the annual inventory carrying cost. So always remember, in this kind of scenario, your average inventory is something like, it comes down, you fill it, again comes down, fill it, again comes down. So you are doing 5 times and applying the normal maths. Your average inventory is Q by 2. So this is the one which you are carrying, and you multiply by the carrying cost Q by 2 into CC, you get the answer 2,000. Next, they say, while reach at Ashok Equipment Company finds that the order cost should have been 20% more than the currently estimated value. What should be the percentage increase in the EOQ? So current ordering cost was 400. They said that you should have 20% more. So with 20% more, it becomes 480. Now use 480, find a new EOQ. New EOQ comes to 190.89, and they are asking percentage increase. So 2190.89 minus 2000, which becomes 190.89. You multiply and you get the answer 9.5%. Okay, next question. This is also an important. Suppose a company wants to expand its logistics network and locate a new warehouse within the network of 3 existing facilities. The coordinates of the existing facilities are this, this, and this, and the respective outbound goods volumes are 2,500, 1,300, and this. Determine the location of the new warehouse. So remember this, always use the COG model, center of gravity model, for these kind of questions. So X will become, take horizontally 200 into demand plus 300 into demand plus 100 into demand, and then you divide by the sum of the demand. So here you get 158, and vertically what y axis you get 114. So this how you do that. So remember, COG will give you the correct one. Okay, with this we have finished that question paper also. Any doubt, anyone till now?
No doubt.
Okay. Okay, so we start April 23, and so this is a metropolitan matrix. This is Manhattan, nothing. So all of us, we know that we can do. Okay, this is a question. Okay, so for certain activity, this activity chart has been given. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 activities are given. The activity time is given in minute, and they have also given the preceding activity, that what is required for that activity to happen. So see in this first, like we find like total number of workstations. So to find the number of workstations, what do? We find the min cycle time. So here the min cycle time is always the slowest one. So in this case, it is 19. This is the slowest station. And then we take the total time, 109. So number of workstation is equal to total time divided by the min cycle time. And you change it to the next integer. So this becomes 6. Now with this 6, they have asked that which of the following is or are an allowable grouping of activities to produce the product if the target is to have the maximum possible output. So if you check them one by one, you will find that here this is not matching. First of all this time has to be less than 19. So that is the first constraint. Second constraint is that the activity which you are starting, its preceding activity should have completed. So when you apply those two constraints, you will get this answer. I had only one doubt in this question, which I later on got clarification, that this is the answer which is having all the constraints satisfied. Other than that, that for A10, A9 was the preceding activity. You can see here for A10, A9 is the preceding activity.
Yeah. Yes.
So then later on I got the clarification from the instructor that till the time is matching, you can have these two activities on the same workstation. And on that workstation, what will happen? That first it will do the A9 and then it will do A10.
Okay.
Okay.
Here also the ordering is being followed. Okay.
Yeah. So here, see, time 13 plus 5, 18 is less than 19. So that is achieved. Okay.
Got it. Yeah.
What is the balanced delay of the line? Balanced delay of the line is you find the percentage idle time. So when you will do the calculations, you will get 5. If day has 2 shifts and each shift is of 8 hours, then what is the per day maximum output that can be achieved from the layout? So he has given the time. This is the time 28 into 60 because everything is in minutes. And one product you are producing every 19 minutes as per the workstation. So total output will become time divided by the cycle time, min cycle time. So this becomes around 50.56, which is equal to 50. That's how you get it. Okay, again, this is the question. The Bellman equation is solved using backward recursion for a 3-period inventory model. The ordering cost is rupees 2,500. The inventory holding cost is 250. The material cost is 15,000 and the item is sold at 30,000 per unit. The inventory can hold at most 30 units at any given time. Answer the given questions. So this question they have asked 2 times again the PYPs. So we'll solve it. So what it is saying that there is a 3-period inventory model. So there are 3 periods, 1, 2, 3. The ordering cost is 2500 per order. So if you have to order 1, so 2500 is your CO. The inventory holding is CC is 250 per unit. The material cost which you purchase is 15,000. So cost price is 15,000. The item is sold at 30,000. This is the selling price is 30,000. So from here directly we can find that profit per item is 15,000. Okay. Now they are saying that there are 20 units at the start of the second period. Second period is 20. The demand in the period is 20 the possible future profit is rupees 747500, irrespective of how many units are in the inventory at the end of the second period. So what it says, that irrespective of the state here, the profit in this last stage is 747500. Then what is the maximum profit that can be generated up to the period 2? So they are asking that what is the maximum profit which can be generated up to period 2. So in Bellman, what do? We start from the end side. So here profit is 747500. Now when S2 is 20, and he has also written that when the possible actions are restricted to ordering 0, 10 or 20. S2 is starting 20, demand is 20. So he can have all the three options. He can order 0 also, he will have 20, consumes 20 or sells 20 and does not hold anything. He orders 10, so he becomes 30, consumes 20, carry on 10 or 20. So if you think logically, you don't have to do anything. You know that 0 will give you the maximum profit. Because here in these two cases, the carrying cost will come. Am I clear here? Is this understood?
Yeah, got it. Yeah.
Okay. So you just find for 0. So at S0, what he will do? There is no ordering cost, no material cost, no carrying cost. Okay. And how much profit
Okay.
he will make? Hello.
Yeah.
And so there is no carrying cost, max profit up to. So his F202 will become 30,000 into 20. So there are 20 items are there, and we knew that just hold on. We knew that on everything he is making how much profit? 15,000.
Yes, profit 15,000. Correct.
15,000, na?
Yes.
So his maximum profit okay, which he can make is 3 lakhs.
Correct.
So his profit will become up to profit to just hold on. Somewhere I have made a mistake. Uh, his 20 is 20. He's not ordering anything. 30,000 into 20. He sells. Okay. Sorry. So this 15,000 which is there. See this 15,000 which is there. He purchased this thing in the earlier one. Okay, here he has got 20 items and he's selling for 30,000. So this entire thing is coming for the profit in the stage 2. So this becomes 6 lakhs.
But carrying cost should be there, no? But
So that was for stage 1. We are not considering stage 1 here. The question is asking what is the maximum profit that can be generated up to period 2. So we are starting from here, coming up to stage 2 only. Okay, so he did not incur anything on purchasing. 0 order cost, material cost 0, carrying cost 0, and he's selling. So this is his entire profit. Okay, and you add with this 747500. So this will be your maximum profit, which can be generated up to period 2. Okay.
Got it.
So logically, I will say don't even do 10 and 20 if it is 2020. So in case they would have given you a thing like they can ask in one of the question they have asked like similar question, but they have said that in stage 2 now your starting is 10 and your demand is 20 and you can order 0, 10, 20. So logically how much you have to order? You should order only 10.
Yes, only 10. Correct.
Okay, because then you will not have any carrying cost and but in that case your profit will change. In earlier your profit was 6 lakhs.
Yes.
Here what will happen that you will order, so there is a 2500 into 10. This is your ordering cost.
Yes.
Okay, so this is ordering cost is 2500. Sorry, Ordering cost is 2500.
Only
This is the fixed
2500.
cost.
Yeah.
And there was also 15,000, no? 15,000 per item.
Yes, correct.
Okay, so this will become your cost of purchasing, and selling is your 20 into 30,000. So this will become 6 lakhs, and profit will become 6 lakhs minus this much. And this profit you add to 747500. Is this clear?
Okay, now got it. Okay, now I understood the previous and this. Yeah,
Yeah.
got the difference.
Okay. Because there is a question okay, on the same lines in the period. Okay, if the demand in the second period is not deterministic and follows a distribution as given in the table below, then what is the probability that period 2 will end with 0 units in inventory if period 2 starts with 20 units in inventory and order is placed for 20 units? So period 2, it has got 20, starts with 20, and order is placed for 20, and demand was how much? Okay? Demand distribution they have given this much. Okay, so this becomes 20 plus 20. How much okay, is become 40? He started with 20 and ordered 20. Okay, so he has got how many? How much now? 40.
Yes.
And what is the probability of 40? Is 0.125. So answer is 0.125.
Okay, this
Is
is
this
based on
clear?
probability. Okay.
If the demand in the second period is not deterministic and follows a distribution as given in the table, then what is the probability that period 2 will end with 0? 0 means he had 20 and they have said order 20. So he has to consume 40, then only it will start with 0.
Yes,
So the,
of course.
so the demand has to be 40. And
Yes,
what is the probability for that? It is 0.125.
0.1.
Okay.
Good. Yes.
Okay. Okay. This is the same question we have done that earlier.
Yeah, yeah. We can
Booking
check.
flight one. Okay, so I'll not do this. Protection level already I have covered. Booking limit I have covered. Okay. Okay. Now this is another a very interesting question. I will take some time on this. And a company needs to ship two products, A and B, to a foreign country. This is from week 10, if I'm not wrong, week 10 or 11. Two models of transport, air and sea, are available for shipping. The demand in the foreign market is stable at 100 units per week for each of the two products. Products A and B cost rupees 20,000 and rupees 10,000 respectively. If the company chooses to use air as the mode of transport, then it must ship 100 units in every shipment. On the other hand, if the sea is chosen as the mode of transport, then the shipment size must be 400 units at least. Air shipment takes 1 week to reach the destination, while sea shipment takes 4 weeks. Items shipped by air incur a cost of rupees 360 per unit, by sea 90 per unit. If the company incurs 20% of the per unit cost for a product as the cost to hold the item in inventory for a year, answer the given questions. Okay, so here in this question, the important parts are what? First of all is the demand, and demand for year. The price. Now for item A, for example, the demand is how much? It is 100 units per week. So you convert it to the year. Okay, 100 into 52. So your yearly demand becomes 5200. Price is 20,000. For B, the demand is same, price is less. Now for C, the minimum block which these items can be carried is 400. For air, it is 100. For time, C takes 7 to 4, 28 days. I have converted weeks into days. And for air, time is 7 days. What is the rate? Here, rate is 90 rupees per unit. And here, the rate is 360 per unit. Ordering cost, they have not given. So it is 0 for both. Holding cost they have given, it is 20% from this part, 20% of this. So the holding cost for this is 4,000, and which is same for both, 4,000, 4,000. For B, this is same, only the holding cost changes because the price is 10,000. So holding cost changes. Now when you transport something, what are the things which are involved, okay? When you see when shipping, what is the total inventory or thing? So I'll cover certain basics here. So when you order something, so there is a transportation cost. First of all, there is a ordering cost. Number one. So ordering cost is how much? It will be
Or
how many times you are ordering?
yes, correct.
Okay, okay. Second is your transportation cost.
Yes.
This will depend on your rate.
Yes, based on
And
per unit.
third is your holding cost. Now holding cost also has two parts. One which you are holding in the inventory, which we covered earlier here, which is like this. Okay, Q by 2. And the
Yes.
second is the inventory which is in transit. Suppose your inventory is there on the ship and it is taking 28 days. So this is also your holding cost.
Yes, correct.
Okay, so this is known as a transit inventory cost. Okay, and we'll see how to solve these questions. Okay. So the we have gone through the basics. Set out is complete. Now the first question is, when shipping product A by air, what is the total inventory in the system? What is the total inventory in the system? So by air we know minimum Q is how much? 100. Okay. So what will be the total number of lots? Total number of lots will be total demand divided by 100, which comes
Yes, correct.
52. Now I
Yes.
covered inventory in the system comprises of two parts. One part is the which you are holding in the inventory, and second which you are in the transit. Okay. So your full demand which is there, it will be in transit for 7 days at some point of time.
Okay.
So first part becomes 100 by 2. Second is total demand into 7. This is days. You convert it to year divided by 365. Okay.
Okay.
And then you use this 52, that in 1 year there are 1 week and there are 52 weeks.
Okay.
Okay, so here it becomes 150. So this will become approximately 100 and this becomes 150.
But here my doubt is right.
Yeah,
Like Q by 2, that is
yeah.
in inventory means fine. It's filling and going up. But this is like in transit, right? In transit also, will it be applied the same?
Yes, yes. See, in the transit, what is happening? Your total time is the total demand is how much? 5,200.
Okay.
And this
Mm-hmm.
demand which is there, whatever you are ordering, it will be during transit for how much? 7 days.
Yes.
So there for this, your cost of this is the inventory in transit. We are not finding the cost. This is presently we are finding the inventory. So inventory, holding inventory is Q by 2, and this is the inventory which will be in transit, and you divide
Okay.
by 365 for year.
Second part is fine. Only the first part I confirmed. Nothing
This
else.
is the inventory which is there in your go down.
Okay, inventory. Go down.
Okay,
Okay.
okay.
Okay, okay, then fine.
You order. Okay,
Got it.
this is the Q by 2 which we are using in the EOQ model.
Okay. Got it. Got it.
Okay.
Yes. Yes.
So this is clear. So we got here for this. Now when shipping product A by C, what is the total inventory? Now by the C, only the Q changes 400.
Actually, air takes 7 days. Okay. Got it.
This is the
Okay.
Q. What is the minimum number of items which you can carry? It is like a
Okay.
lot. Okay. So in
Okay.
C, 400. So
Yeah.
total number of lots become 5,200 by 400, 13. Okay.
Yes. Yes.
You
Correct.
use the same formula. Inventory in the system will be Q by 2. Then
Correct.
5200. Now number of days become 28.
As it is shipped. Yeah.
Okay. So you get 600. So this is for the
Got it.
inventory in the system. So remember, inventory in the system is Q by 2 plus demand into time. Okay.
Got it.
Okay.
Yes.
Now total cost is how much? Total cost will be ordering cost plus transportation cost plus holding cost.
Yes. Correct.
Okay. Ordering cost formula we know from EOQ is D by Q into CO.
Yes. Correct.
Transportation cost will be demand into the transportation cost.
Correct. Yeah.
Holding cost now will be Q by 2 into CH and item in transit into CH into time.
Yes. Yes.
Okay.
Yes. Yes.
So now what is the total cost that is incurred for the movement of product B? Now here has come product B. Earlier we calculated for product A. Okay. So for product B, min is 400 because it is, sorry, here it is 100. This will become min is 100. This is by air. Okay. 100. Total cost is equal to ordering cost plus
Yes.
transportation. Hello.
Yeah. Yeah. Correct. 100 only.
Yeah. Transportation cost plus holding cost. Ordering cost in this case, they have given 0, that there is no ordering cost. Okay. They have not mentioned anywhere. There is no any ordering cost. Transportation cost is 5200 into 360 by air rate. Okay, so this is the transportation cost. Holding cost now for product B, we know we calculated the holding cost. Holding cost was how much? 2000.
2000.
Okay.
Yes.
So Q by 2 into 2000 plus 5200 into CH into time. This is your that you calculate. So this will come 3 lakhs, 300,000, and you sum this up, so you will get the total cost. Okay.
Yes. Yes. Got it. Yeah.
Now they have asked the same for C. So for C, what will change? Your Q will change and your rate will
Days.
change. Okay.
Yeah.
Only those two things will change, and you calculate, you will get the answer. And
Okay.
for A, I will leave up to you. You find for A also. This is mentioned in the document. But A, you do your calculations separately so that you build your confidence to solve these questions. Okay.
Sure. Sure.
Okay. But I can say with probability 80% that a similar question will definitely come in the exam. It's important. Okay.
Okay. Got it. Yeah.
Okay, now the next question is COVID. They have asked TSP. It is the company had asked its salesmen to visit a set of locations. All the salesmen must come to the office every day. So this I will leave it. Okay, it's a simple question. You just go through the solution. You will get the clue. It's an easier question. EOQ straight away formula is there. This is a similar question. Okay, this is again a EOQ question. Median, and all these are theoretical. Theoretical ones are there. So most of the questions, this is similar question, we have solved it.
Yeah.
Okay.
Repeated on. Yeah.
Okay. Only in this case, there is only one difference I will mention here. They have given here that a product is produced every 20 minutes. So here the min cycle time they have given is 20. Okay. Remember this only.
Okay. Okay. Not
Whereas
19.
okay, if this is not given, then we will take minimum cycle time is equal to 19. Okay, this is the only difference.
Mhm. Got it. Yes.
Yeah. Okay, Bellman equation we have done. Similar question. This demand function we have done. Okay, this similar question we have done. Okay, so this is repetitive. So this transportation question, please do okay yourself. Okay.
Sure. Sure. Sure.
Okay, so with that, I will end this session. In case anyone having any doubt.